All right, let's dive right in. We're going to tackle a question that pretty much everyone who deals with networks has asked at some point. How fast is my connection? Really? Today, we're going to break down exactly how to measure your network's true, real-world performance.
You know how it is, right? You're paying for a 1 gigabit link, the marketing materials all say 1 gigabit, but when you actually try to move a big file, it just never seems to hit that magic number. So what gives? Well, it's because that advertised speed, that's not the same thing as the actual performance you can achieve day to day.
So what we're actually looking for is something called TCP throughput. This is the number that matters. It's the true measure of what your connection can actually deliver from one computer to another, once you factor in all the real-world stuff. Think of it this way. The protocol overhead is like the weight of the shipping box and the label, and conditions like latency are the traffic on the road. We're not measuring how fast the truck can go, we're measuring how many packages actually show up at the destination per second.
Okay, so to measure this, we obviously need the right tool for the job. And in the world of network testing, there is one clear, undisputed champion that everybody uses.
And that tool is IPERF3. This is the absolute go-to utility for professionals who need to get accurate, reliable answers about network performance. It's powerful, it's trusted, and it's exactly what we're going to use to figure out what's really going on.
So why is IPERF3 the king? Well, for starters, it's open source and used everywhere. It works on a really simple client-server model. One machine listens and the other one sends a bunch of data. Its whole reason for existing is to find the absolute maximum bandwidth you can shove through a connection and then give you these great detailed reports to look at.
Okay, enough talk. Let's get our hands dirty and run our very first test. You're going to see it's actually way easier than you might think. We'll just walk through it together, step by step.
First things first. On one of your machines, we'll call this one the server. You just open up a command line and type this, IPERF3-S. That's it. You've just told IPERF3 to start up and listen for a connection on its standard port, 5201. Simple as that.
Awesome. Now, hop over to your second machine, the client. Here, you'll type a very similar command, IPERF3-C. But this time, you follow it with the IP address of the server you just started. This tells the client, hey, connect to that server and start blasting data. By default, it'll run the test for a solid 10 seconds.
And boom, after those 10 seconds, you get a summary that looks something like this. So what are we looking at? The sender line tells you the average speed from the client's point of view. In our example, 940 megabits per second. The receiver line shows what the server actually got, which is almost always a tiny bit less. That tiny difference, that's the overhead we talked about. But that number, 940 megabits per second, that is your real TCP throughput.
And that right there is the key takeaway. This number isn't some theoretical maximum, no way. It takes into account everything along the path. Your computer's network card, every router, every switch, every firewall in between. It is absolutely the whole enchilada.
So a quick 10-second test is great for a gut check. But if you want to test like the pros and get a really solid, robust picture of your network's health, we need to use a few more advanced tricks. Let's look at 3 of the most common and useful flags. Adding -T30 just tells IPERF3 to run the test for 30 seconds instead of 10, which helps smooth out any little blips and gives you a better sense of sustained speed. Now, -P4 is really interesting. This runs 4 parallel data streams at the same time. It's a fantastic trick for truly maxing out a link. And finally, -R just reverses the direction, testing from server to client, which is crucial for spotting connections that are faster one way than the other.
So why bother with those parallel streams? Well, sometimes a single data stream just isn't enough to fill up a really fast connection because of a TCP setting called the window size. It's kind of like trying to send letters one at a time and having to wait for a reply for each one before sending the next. It's slow. Parallel streams are like sending 4 letters at once without waiting. You can fill up that pipe way, way faster.
Look, anybody can run a command, but thinking like an expert, that's different. It's about having a structured approach, a real methodology for interpreting results and tracking down problems. So let's elevate our game.
For network pros, that methodology is basically laid out in a document called RFC 6349. You can think of it as the official playbook for how to do this stuff right. It's the why behind the how of just running IPERF3.
And this framework really just boils down to 4 logical steps. First, you measure the basics of the path. You use a tool like ping to find out the round trip time, or RTT, which is just the delay for a signal to go from you to the server and back again. Once you know the path,
You run your IPERF3 tests. Third, you compare the number you got with what you think the link should be doing. And finally, if there's a gap, you start hunting for the problem.
So what happens when your test results are, well, disappointing? You've found that gap. Now comes the fun part, troubleshooting. And here's a fantastic checklist of the usual suspects. One of the most common issues is a firewall blocking that test port, 5201. But it could also be packet loss somewhere. Or maybe the CPU on one of the computers is maxed out, or even some network gear that's deliberately slowing you down. Having a system like this is absolutely key. And all of this, every test, every flag, every troubleshooting step, it all boils down to one fundamental question that every network pro has to answer. Is the problem, the bottleneck, somewhere out there in the network? Or is it right here on the computer at either end of the connection? Knowing how to figure that out, well, that's what this is all about.